Okay, I can create linear combinations of polynomials. So again, this is something that you probably saw a little bit of in Math 3. We're just probably going to take it a step further, a step deeper. But we're going to take kind of what we did in that warm-up there, and we're going to expand it a little bit. Okay, so here's our first example. We've got two functions. We have f of x is equal to x squared minus 5x plus 1, and g of x is equal to negative 3x squared minus 6. We're going to take those two functions and we're going to do several things with them, so that those are going to be our focus. We've got two quadratic functions that we're going to be working with here. We've got x squared minus 5x plus 1 and negative 3x squared minus 6. So the first thing that we're going to do with those two functions is we are going to find the linear combination of 3 times f of x plus 5 times g of x. So this is kind of one of those things that looks a little intimidating because of all the f of x's and g of x's and things like that, but it really is just a simple concept. We're going to put f of x, we're going to put that function in the place of the f of x right here, and we're going to put the function that represents g of x in the place of g of x. So we've got 3 times that f of x function plus 5 times that g of x function. We're just going to distribute and combine like terms. So we distribute the 3 to that first set of parentheses, 3x squared minus 15x plus 3. Distribute the 5, negative 15x squared minus 30. And last step, combine any like terms that we have. We've got 3x squared minus 15x squared, so that leaves us with negative 12x squared. We don't have any other linear terms, the just plain x, so we just bring down that negative 15x. And then constants, 3 minus 30, negative 27. Now, some people will ask this question, do we need to factor that? Yes, that has a GCF. Okay, we could take out a factor of what, at least 3, preferably negative 3, since that 12 is negative, but we're not focusing on that right now. Okay, right now we're just combining the functions, so that's as far as you have to go. You don't have to do any factoring or anything like that. All right, example B, 2f minus g of x. This throws people off because it's in a different form, but it's the exact same thing we just did. But I don't know what form they're going to put on the final exam. So I got to prepare you for both of them. Here's what I encourage you to do. When you see something in that form, I want you to go ahead and just write it like this. Okay, 2f minus g of x. That's not times x, that's of x. F and g mean nothing by themselves. They have to have that x there with them. So that is the same as 2 times f of x minus g of x. Okay, it's the same thing as 2 times f of x minus g of x. You don't do 2f minus g and then multiply everything by an x. You do not do that. You handle it the same way we handled that first problem. So let's do this. 2 times our f function, x squared minus 5x plus 1, minus, and this is what will throw most people, anytime there's a minus involved, whatever follows that minus sign needs to be in a set of parentheses, because you need to apply that negative to that entire function, not just the front of it, not just the first term, but to the entire function. So let's simplify, distribute that 2. So So 2x squared minus 10x minus 2. Distribute the negative. If that were a -2, y'all wouldn't have a problem with doing it, but because it's just a negative, you forget that you need to apply it to everything in those parentheses. So negative 3x squared is positive 3x squared. Negative 6 is positive 6. All right, and then we're just combining like terms like we did before. 2x squared and 3x squared is 5x squared. Again, linear term, the only one we have is the negative 10x. Negative 2 plus 6. Huh? Oh, I was focusing, thank you. I was focusing on my negative. Thank you. Why you should always double check your work. That should be a positive 2 right there. You are correct. So it's plus 8. Big difference there on the end. Did I mess anything else up? Okay, thank you. All right, any questions so far? All right, so that's just the basic simple functions. Let's put a little twist on it. Instead of an x, we've got a number there. 3g minus f, so that's our linear combination of -1. It's not times -1. It is not times -1. It is of -1. So again, if you see it written where there are no x's or numbers beside the g's and the f's, then go ahead and do this. Go ahead and write it out so that you are not tempted to multiply by -1 when you get to the end. And anytime there's a number right here, that means we're evaluating this. This means that we're going to get a number for an answer. We're not going to have any more x's left in our final answer. Okay? Y'all know how to find g of -1, right? You just plug it in to the function. But after we do that, we're going to multiply by 3. So I'm going to take it step by step so we don't get confused. Here's our 3. Our g function was -3 times x squared, but instead of the x, we're plugging in -1 minus 6. Okay, that's just my g of x function with -1 plugged into it. Minus, I had a minus sign, so I'm going to put parentheses. I'm going to take my f of x function and plug in -1. Now, if you need to break this down into some different steps, if you need to do g of -1 by itself, f of -1 by itself, and then plug it into this, that's fine. If you just want to put it into the calculator and do it piece by piece, that's fine. But let me warn you of something that somebody inevitably does every single year. Anytime you square any negative number, what should be the result? Positive number. However, all the time, y'all type it into your calculators just like this, and you get a negative answer, and you just roll with it. But you know the answer is supposed to be positive. What do you have to do? You have to put parentheses around it. Okay, you have to put parentheses around it. So I'm going to go ahead. I'm just going to type in everything that I have over here because I wrote down the parentheses, so I can just go with it and type it in exactly how I have it written with my parentheses over here. No problem. Again, if you're more of a break it down step by step, you're afraid you're going to type something in wrong, there's absolutely nothing wrong with that. I don't have a problem with that at all. Okay. I got -34. Somebody let me know if you agree with that. You got the same thing. Good. Should have got -34 for that answer. Okay. Again, anytime there's a number right there, you're going to get a number as your answer because you're evaluating that linear combination. Okay. Anytime there's a number right there, your answer should be a number, no variables. All right. One step further. Okay, so we've done just a general linear combination. We've evaluated a linear combination. Now this is going to be similar, but after we find our linear combination, instead of plugging in a number, we're going to plug in this expression. We're going to plug in this 1 minus 2a. Now, there are actually two ways that you can handle this one. I'm going to show you both ways because some people like it one way, some people like it the other way. Now, for me personally, since we have the exact same expression right here, 1 minus 2a, I'm plugging that into both of these functions. I personally think that just to do the linear combination part first, combine the negative f plus 4g, simplify that, and then plug it in. Or you can plug it into each function individually and then combine them. All right, it doesn't matter which one. I think it's easier to combine and then plug in. So I'm going to show you that way first. All right, so our combination is negative f. So I've got negative and my f function. So that was x squared 5x plus 1. Do that right? Yeah, x squared minus 5x plus 1. Okay. Plus times my g function, which was negative 3x minus 6. All right, so I'm going to simplify this part first. So distribute that negative x squared plus 5x minus 1. Distribute my 4, negative 12x squared minus 24. Combine like terms. 13x squared plus 5x minus 25. Now, I'm not finished. I've done the linear combination part. I'm finished with that, but I still haven't touched that 1 minus 2a part. So here's where it comes into play. Just like in the negative 1, here, everywhere we see x, we're going to plug in that 1 minus 2a. Let me see if I can kind of color code this here. Okay, so I've taken that linear combination result, negative 13x squared plus 5x minus 25, and I'm replacing the x's with that expression that they want me to plug in, the 1 minus 2a. Now, 1 minus 2a squared. What do we have to remember to handle that? Do we just square the 1 and square the 2a? Nope. Do what? The negative we'll handle the negative in front here in just a second. We want to hang on to that because exponents come before multiplication. So how do we square something like 1 minus 2a? Yes, we write it out twice and we've got a FOIL. All right, so we got to write it out twice in FOIL. So let's do that. We've got negative 13, 1 minus 2a, 1 minus 2a. Now, go ahead and simplify here at the end to start with here. Distribute the 5. So 5 minus 10a minus 25. Okay, let's FOIL that. Whatever method works for you, I do not care. 1 times 1 is 1. Outside and inside give me the same thing. I got negative 2a and negative, I have negative 4a. And then my last two terms, negative 2a times negative 2a. At the end, I like to make sure it's in standard form. So I'm going to write my minus 10a first. 5 minus 25 is negative 20. We're almost there. Distribute that negative 13. So negative 13 plus 52a minus 52a squared minus 10a minus 20. And we got one step left for our final answer, combining like terms and putting it in standard form. So negative 52a squared, we got a minus 10a, so that's 42a, 13 minus 20, negative 3. So that one's kind of lengthy. The biggest reason why it's so long is because you have to square that binomial. So you have to be a little bit more careful with that. But I tried to build it up so it makes sense. It's the same thing every time, okay? Linear combination, just combining those like terms. Be careful when you're subtracting. Be careful anytime a negative's involved. You can be asked to just plug in a number. Okay, you can be asked. Now, we could have also done this in the same way. I didn't do C like I did D. C, I could have simplified 3G minus F. I could have done that combination and then just plugged in negative 1 into that answer, like I did with D. Okay, I did the linear combination first and then plugged in. On C, I went ahead and plugged in and just combined everything. I could have done that on D. The reason why I didn't want to do that on D, even though I could, I didn't want to, because if I did, look, I would have had to FOIL it out twice. So I had an x squared here, and I had an x squared here, and I would have had to plug in to that minus 5x. So even though this was a lot of work, doing it the other way on this one would have been even more work. Okay? You can do it that way. If it makes more sense to you, go for it. It's just going to take you a little bit more time. All right, any questions?